All right, so exponents. When we're talking about exponents, the first term we got to learn is our base. So when we have a base, that's just kind of like our regular number. So in this case, it would be 5, right? Oftentimes you will see our bases with the parentheses around them. That becomes more important whenever we're talking about either negative numbers or if we're talking about having numbers that are, or well, having it not just a single number, but having a set of operations within our parentheses. But so for this example, let's just talk real quick. If we have 3 and then we have our exponent up here, which is our, like, let's say a power of 3, then what we're saying is that we have a 3, okay, and it's going to be multiplied a total of 3 different of those digits multiplied together. So it would be 3 times 3 times 3. The verbiage that I always heard as a child whenever I was learning this kind of stuff when I was a kid in middle school and stuff was you multiply by itself 3 times. And that's kind of misleading because the truth is we're only making 2 separate multiplication steps here. So that kind of verbiage can be a little bit confusing. Let me grab a paper here real quick. Sorry, wipe off my desk here. Okay, so then in this other case, if we have like 6 with an exponent of 4, then we're going to be doing 6 times 6 times 6 times 6. There are 4 6s that we are multiplying in this instance. And whenever we're doing this, like this is where having a calculator comes in handy because this is, I'm used to teaching 4th graders. Okay, so that's going to come out to be 1,296. And so this is what we're looking at when we have an exponent. Now, whenever we're talking about exponents with negative numbers, okay, like if we've got like a negative 5 to an exponent of 3 to a power of 3, then when we're working with that, that negative is still going to stay there, okay? Because whenever we're just saying we have 3 sets of 5 of this negative 5. And so when I always thought it helped to vision negative numbers not being numbers that are this state of negative existence, but more these are just numbers that go in a different direction. And we can see that literally on a number line, right? Where if we have 0 here, 1 is here, but negative 1 is right here. All right. So when we have negative 5 times 3, this is going to be us treating to say, okay, negative 5 times negative 5 times negative 5. And so in this case, we would have, negative 125, right? Whenever we are multiplying by negative numbers, it's I kind of misspoke earlier. Because if we're doing negative 5 times 3, or squared, let's say, okay? If we're doing negative 5 squared, so negative 5 times negative 5. In that case, that's going to end up with us having a positive 25. If we were to then multiply by a negative number a third time, which is why we ended up with that negative 125 earlier when we multiplied by that negative up here, we're going to end up with that negative 125. Because those negative multiples, every time we multiply by them, it kind of swings them in the other direction while still increasing that overall amount, right? So if we're at negative 125 because of negative 5 to the third power, if instead we did negative 5 to the fourth power, we would see that negative 125, which we got from here, we would see that multiplied times negative 5. And then when we multiply two negatives, we end up with a positive. I hope this helps. I realize it was a little bit rambly. Hopefully it helps you out. If it doesn't, I will happily kind of figure out what else I can show you or what else I can help you with. Best of luck. Take care of yourself.